The whole point of this whole quarter of trigonometry comes to this right here, is we want to find angles that produce these ratios. And this is what we call trig solving. And I'm starting with some really easy ones, cosine x equal to a value. But this is still solving, so we'll get more complicated later on. But for right now, you go on the unit circle, and cosine was the x or the y part coordinate. It was the x part, right? It's the x part of the coordinate. So starts at 0, goes to 1, and this might be super helpful to you. I hope it is. Square root of 3 over 2 is more than a half. It's actually going to be about here. That's the x value, square root of 3 over 2. So what will happen is that these are the two places, pi over 6 and 11 pi over 6, between 0 and 2 pi, that this is true. So what you would say is x here is equal to pi over 6 or 11 pi over 6. And I almost like theta a little better because we refer to the coordinates as x and y. If you want to call these theta, that's fine. There, we solved it. Now, if somebody said find all the possible ones that exist in the universe, you would go plus what? 2 pi k. And you do it to this one too. Because adding 2 pi, will that get me to 11 pi over 6? Will that get me to 11 pi over 6? Will it, from pi over 6? No. So we have to list both of them, and then we can add the 2 pi k. And we really should write where k is an element of the integers. That's a shortcut. You like the shortcut. Element e, integer z. Kind of rhymes. This is where it gets good. Now, cosine 2x equals square root of 3 over 2 is an entirely different animal, because hold your finger up here, we're going to make a cosine curve. Goes down, comes back up between 0 and 2 pi. Goes down, comes, that's one cycle. How many cycles are there if it says cosine 2x? 2. So it's going to go down, up, down, up. All right? Look at what the graph is going to do. Here is the cosine x. This is 1, this is 0. Notice that square root of 3 over 2, you're going to get two places. 1 pi over 6. Another 11 pi over 6. That kind of makes sense. But when we do the cosine 2x, what happens is we're going to get how many answers now? I'll use smiley faces because it perks me up. Come on. Where are you, smiley faces? Here you go. 1, 2, 3, 4 solutions now. Does that make sense? We had 2 because there was one cycle between 0 and 2 pi. That gave me these 2. But now I'm going to have 4. So here's a way to do it. I'll show you an easy way, and I'll show you a harder way. I won't tell you which one this is. We're going to have 4 answers, one for each smiley face. Okay? The first 2 are going to be the same as what we did before. Pi over 6 and 11 pi over 6. So write those down. By the way, if you learn one thing today, this is what I want you to learn. It's tricky, and we use it a lot. Now, I'm going to do something kind of weird. I'm going to go 2 cycles. Now, you might say, well, we're not going to go beyond 2 pi, but we are for a moment. So what I'm going to do is I'm going to stretch. I'm going to add 2 pi. Now, 2 pi is how many pi over 6 to get 2 pi? 12 pi. Thank you. That was really quick. So we're going to add 12 pi over 6 to each of these. So pi over 6 plus 12 pi over 6 is 13 pi over 6. 11 pi over 6 plus 12 is 23 pi over 6. Okay? doing okay? Now solve for x. What do you do to solve for x? Algebraically, what do you do? Divide by 2, right? Now you can see why I did twice as many, because when I divide by 2, it's going to bring it down between 0 and 2 pi. So I'm going to divide by 2, like that. And so my answer for x, or theta in this case, is going to be pi over 12. That's this first one, first smiley face, pi over 12. The second smiley face is going to be 11 pi over 12, which is about halfway. Okay. The third smiley face is going to be 13 pi over 12, which is going to be really close, and it is, really close to 11 pi. And then the last one is really close to 2 pi, 23 pi over 12. What's neat about this is that these are all between 0 and 2 pi. And the reason we find all those between 0 and 2 pi is all because of Garrett, because he would want to find all the possible ones that exist in the universe, and you just go plus 2 pi k, plus 2 pi k, plus 2 pi k. And you got all of them that exist in the universe. Pretty amazing. And by the way, those k's are negatives too. They could be positive integers or negative integers. So you get all of the possible going forward or backward. This was the goal of the whole quarter, is that you're able to find these. What do you think? Do you want to see the easier way? Okay. The easier way is less conceptual, but what you do is you do what we did for, I like to say, cover this up and just find the two answers. The two answers were theta equal to pi over 6 and theta equal to 11 pi over 6. Okay? And remember, this is 2 theta. 2 theta. And then we're going to do what Garrett did before. We're going to add 2 pi k, like that. So 2 theta equals pi over 6 plus 2 pi k. 2 theta equals 11 pi over 6 plus 2 pi k. And then what do you think we're going to do? Take a wild guess. What are you going to do next? We want to solve for theta. What are you going to do next? Divide by 2. So I'm going to do that. Divide by 2. So this is going to be theta equals pi over 12 plus pi k. And this one is going to be 11 pi over 12 plus pi k. Now, pi over 12, pi in terms of over 12s would be 12 pi over 12, right? That's pi. Okay? So what's 12 pi over 12 plus pi over 12? 13 pi over 12. What is 12 pi over 12 plus 11 pi over 12? 23 pi over 12. So you got them that way too. These are all covered in there. If you want the between 0 and 2 pi, you just do the first 2 pairs. Do you like this way better? It's quicker, isn't it? It's quicker. Okay. Good. This can go a number of different ways. You can also do this with sine x over 2. You can do it with tangent pi x over 3. We're going to just do this real quick. So on the circle, sine is the y. So we're going to go in the middle here. We'll have 2. Sine is 0, goes up to 1. This one is a half in the middle. What arc length is this, and arc length is this? Pi over what? 6, and this is how many pi over 6? 5. Good. So what you would do is you'd go x over 2 is equal to 5 pi over 6 plus 2 pi k. That's one. And then the other one is going to be x over 2 equal to, oh, I should have done it doesn't matter which one you do first, plus 2 pi k. I probably would switch the order here. I'd do this one first. Okay? Then you just multiply by 2. So x is going to be equal to 2 pi over 6 plus 4 pi k. And then this one's going to be x is equal to 10 pi over 6 plus 4 pi k. And you're done. By the way, the values between 0 and 2 pi are just going to be these first two. Because as soon as you add 4 pi k, it's going to be too big. All of these are R3s, yeah. Anything with the, yeah. Is it sort of making sense? Yeah, it's tough. Okay, here's all I'm going to have you do. For this one, cover this up. Tell me the two places where the tangent equals -1. I want to see what those are. Pi x over 3 equals, what are those two? Go ahead and turn to your neighbor, see if you can find the two places on the unit circle. You cover this up. Cover, maybe I'll draw it for those at home. I'm covering this up. Like that. What two values are going to be true to get the tangent equal to -1? Go ahead. See if you can figure it out. As soon as you got it, raise your hand that you have. Excellent. Right here, tangent x equal -1. That's 3 pi over 4. Perfect. This is one of them. So pi x over 3 equals 3 pi over 4 plus 2 pi k. And then the other one, what do you think, Owen? 7 pi over 4. Perfect. This one's straight across here. This will be tangent theta x equal to -1. It is 7 pi over 4. So can you see why I made you learn that unit circle? This is it. This was the purpose. 2 pi k. Now, to solve for x, what we're going to do is we're going to divide everything by pi, which I like. I'm going to get rid of all the pi's everywhere. And then I'm going to multiply everything by 3. So this will be x equal to 9 pi over 4 pi, or just 9/4. Pi's cancel out, plus 6k. This one is going to be 7/4 plus 6k. And there you have it. How to solve with multiple periods or single periods using the unit circle. Now there's an infinite number of other ones to do. For example, we can start getting into formulas and rewriting things. But whenever you want to solve for any equation, you've got to get it down to a function alone. For example, what if I divided both of these by cosine x? Now I'm going to get the square root of 12 tangent is equal to 2. So you're going to have tangent x equal 2 over the square root of 12. And that one might be a little hard to know. You might want to use your calculator for that. But remember, square root of 12 is the square root of 4 times square root of 3. What's the square root of 4? 2. So 2 over 2 square root of 3 is 1 over the square root of 3, a little rational values. And then I'm just going to tell you real quick, the arc or inverse tangent of 1 over the square root of 3 is pi over 6. The arc tangent of 1 is pi over 4. The arc or inverse tangent of square root of 3 is pi over 3. These are 3 you'll want to memorize because they'll come up a lot. And if you don't have a calculator, you're expected to know these. 1 over root of 3 is tiny, pi over 6. Square root of 3 is bigger, pi over 3. And inverse tangent of 1 is where the x and y's are the same, pi over 4. So for this one, your answer is x equal to pi over 3 plus 2 pi k. But on the unit circle, where's the other place where this is going to be true? Down here, right? So I think that's 4 pi over 3. So we're going to have 4 pi over 3 plus 2 pi k. So there's how you throw the tangent into the mix. This you'll use your calculator, but I'm not going to worry about it. Go to your problems, and here's day 1. You're going to get some practice with these multiples, and then lots of practice with the multiples. This one looks like an R4 that we had at one time. If I took the square root of both sides, I would get what on this side? Make my day. Almost plus or minus. If you forget the minus, you're going to miss half as many answers. There's going to be a bunch of answers for this, a bunch of answers for that. Okay, that's my hint for that. Everything else should be fine. Looking good. 52. This one is a thinker. But I'm going to give you a hint. By the way, I saw that movie a couple weeks ago. It was really good. Coco. Oh my gosh. What a great show. Fantastic. All right. So that's what you're going to work on. And we're going to do one before you leave, but this is it for the video.